Have you ever wondered if you could peek into the future, maybe see what your life looks like in 50 years? Or what if you could go back, change one decision, and rewrite your destiny? Time travel has mesmerized humanity for ages, fueling blockbuster movies, mind-bending theories, and countless late-night debates. But how much of it is science fiction, and how much is on the verge of becoming science fact? In this video, we're diving into the real physics behind time travel. From Einstein's groundbreaking theories to the newest research that's pushing the boundaries of what we thought was possible. Strap in, our journey through time starts now. Before we can even imagine hopping between centuries, we need to pin down what time really is. Not just the ticking clock on your wall or the minutes counting down on your phone, but the fundamental thread that weaves our universe together. According to Einstein's theory of relativity, space and time merge into a single fabric called spacetime. Picture it like a giant cosmic trampoline, where planets and stars create dents in this fabric, and those dents affect how time flows. On this trampoline, we move freely in 3 dimensions, up, down, left, right, but time is like a one-way street pushing us forward. Or is it? Could there be secret pathways that let us spin the arrow of time in reverse? Physicists define time as another dimension, but unlike physical distance, we don't have the same freedom to wander. We're stuck on a cosmic conveyor belt moving forward, at least so we think. In 1905, Albert Einstein shattered everything we thought we knew with his theory of special relativity. One of his wildest findings? Time is not the same for everyone. This phenomenon is called time dilation, and it means that your perception of time literally changes depending on how fast you move. Imagine traveling near the speed of light. For you, only a few hours might pass, while back on Earth, years could have gone by. Crazy, right? Well, it's not just a mind trick, it's real science. We've even observed tiny glimpses of time dilation with astronauts aboard the International Space Station. They come back to Earth having aged just a fraction of a second less than the rest of us. So, in a sense, time travel to the future has already been proven, just in very small increments. The faster you go, the bigger that effect becomes. Moving forward in time is one thing. What about traveling backward, seeing ancient civilizations or meeting your younger self? That's a whole new level of complexity. Enter wormholes. Picture these as cosmic shortcuts, or tunnels, that connect 2 distant points in space-time. If they exist and we could stabilize one end in the past and the other in the present, you might step through and land in a completely different era. Then there's the concept of tachyons, particles that, if real, would move faster than light and possibly open doors to backward time travel. So far, tachyons remain purely theoretical, no one's spotted one yet. But even the possibility has scientists wondering, could these exotic ideas be the key to rewriting history? Of course, time travel isn't just a physics puzzle, it's also a logic maze. Take the infamous grandfather paradox. If you traveled back and prevented your grandparents from meeting, how could you have been born to travel back in time in the first place? These paradoxes rip open questions about cause and effect. One way around it is the many worlds interpretation of quantum mechanics, which suggests each trip back could spawn a brand new timeline, leaving your original reality intact. Sound complicated? It is. And that's part of what makes time travel so incredibly fascinating. The blunt truth, no one has definitively proven backward time travel to be possible. But traveling into the future at different rates? That's already happening, thanks to relativity, and we rely on it more than you might think. Take GPS satellites. They're so high up and move so fast that they experience time slightly differently than we do. Engineers have to adjust for that effect daily to keep your GPS accurate. So, could we ever crank that up to a dramatic time jump? Maybe. If we had the technology to approach light speed or harness extreme gravitational fields, like near a black hole, time dilation becomes massive. The question is, can humans survive those conditions? And can we even build a machine that withstands such extremes? From closed time-like curves to quantum entanglement, researchers around the world are probing every nook and cranny of physics to see if time can bend, or even break. Institutions like CERN, with its Large Hadron Collider, are smashing particles at near-light speeds to uncover the secrets hidden in the deepest layers of reality. While we're still far from stepping into a time machine, each new discovery in quantum mechanics or gravitational physics nudges us closer to understanding how time itself operates. The more we learn about time, the more we realize it's flexible, mysterious, and full of surprises. So, is time travel around the corner? Not yet. But we already see hints of it in the cosmos, and science is pushing the boundaries every single day. Maybe the real question isn't if time travel will ever be possible, but when we'll discover the breakthrough that changes everything. What do you think? Will we ever build a real-life time machine, or are we forever locked on a one-way highway to the future? Let us know in the comments. If this video got you thinking, or blew your mind, smash that like button, subscribe, and ring the notification bell. Because you never know when we might unlock the secrets of time. Thanks for watching, and who knows, maybe we'll catch you in another timeline.